What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA 220-1001 examination. So let's get into it. In this video, we are going to discuss wired and wireless SOHO networks. You will learn router switch functionality, access point settings, IP addressing, NIC configuration, end user device configuration, IoT device configuration, cable DSL modem configuration, firewall settings, QoS, and wireless settings. A SOHO access point is a device that creates a wireless LAN, typically found in office buildings. An access point connects to a wired router and projects a Wi-Fi signal to a designated area to provide a secure way for users to access the internet and local network resources. Depending upon how the device is configured, it can also become a magnet for attacks. Now, to configure a router settings, connect to the router via an Ethernet cable or wirelessly and use the manufacturer's instructions on the default IP address. The IP address typically looks similar to 192.168.0.1. To connect, just open a browser and enter the IP address of that router in the address bar and then simply press enter. Channels. The 2.4 gigahertz spectrum on a wireless router is divided into 11 channels. Only 3 channels within this spectrum do not overlap. Those are channels 1, 6, and 11. For the best wireless signal in the 2.4 gigahertz spectrum, select one of those channels. Now, some SOHO routers feature an auto setting that enables the router to use the least active channel, but you can use a Wi-Fi diagnostic utility to find the least used channel if you prefer to set up the router manually. So here are some of the basic steps that you would use to change the channel used by a wireless network. One, you're going to log into the router. You're going to navigate to the wireless configuration dialog. Then you're going to select a different channel, typically channels 1, 6, or 11 when you are using the 2.4 gigahertz networking because they have less interference than other channels. And then you're going to save the changes and exit the wireless configuration dialog. And as you can see in this screenshot here below, these are some of the various channels that you can pick from on a wireless router. Network address translation is a method of remapping an IP address space into another by modifying network address information in the IP header of packets while they are in transit across a traffic routing device. So in layman's terms, NAT is the process where a network device, usually a firewall, assigns a public address to a computer or a group of computers inside a private network. The main use of NAT is to limit or hide an entire IP address space on a LAN for both economic and security purposes. This functionality is typically built into a router. When NAT is implemented, before an IP address on the LAN can communicate with the internet, the IP address has to be converted to the public IP address of the router. This allows for the router to appear as if it is the only device making a connection to remote computers on the internet, which provides safety for the computers on the LAN. It also allows a single IP address to do the work for many other IP addresses in the LAN. NAT is performed automatically on SOHO routers when connected to an IP version 4 network. NAT is not necessary on IP version 6 networks because IP version 6 is much more secure and has no shortage of IP addresses. Port forwarding or DNAT. So in computer networking, port forwarding or DNAT, which stands for Destination Network Address Translation, is an application of NAT that redirects a communication request from one address and port number combination to another while the packets are traversing a network gateway, such as a router or a firewall. In layman's terms, port forwarding allows remote computers to connect to a specific computer or service within a private LAN. An example could be an FTP server residing inside of a LAN with the IP address of 192.168.1.240 with port 21 open to allow for external computers to connect to engage in file transactions. In order for external computers to connect, These devices would need to know the IP address of your router. So let's just say your router's IP address is 68.54.121.93. And it would also need to know the appropriate port number, such as port 21. Once the external computer is granted access to the LAN, the external device's packets will be forwarded to the FTP server at 192.168.1.240 port 21. So here's an example of single port forwarding. So all traffic coming in on 8090 on that port using the TCP protocol is going to be forwarded to the IP address 192.168.1.190. Port triggering is a configuration option on a NAT-enabled router that controls communication between internal and external host machines in an IP network. It is similar to port forwarding in that it enables incoming traffic to be forwarded to a specific internal host machine, although the forwarding port is not open permanently and the target internal host machine is chosen dynamically. Port triggering is useful for network applications where the client and server roles must be switched for certain tasks, such as authentication for a service called Internet Relay Chat or IRC, which allows for the opening of an outgoing port or range of ports on demand. DMZ, so a demilitarized zone, which is sometimes referred to as a perimeter network or a screen subnet, is a physical or logical subnetwork that contains and exposes an organization's external facing services to an untrusted, usually larger network such as the internet. The purpose of a DMZ is to add an additional layer of security to an organization's LAN to where an external node can access only what is exposed in the DMZ, while the rest of the organization's network is firewalled. The DMZ functions as a small, isolated network positioned between the internet and the private network, and if its design is effective, it allows the organization extra time to detect and address breaches before they would further penetrate into the internal networks. Here is a diagram of how a DMZ functions. So on your left here, you have the enterprise LAN, that is the internal network. They are protected by our firewall right here. On the other side of this firewall, they might have a mail server, web server, and some type of router inside the DMZ, which is then protected by another firewall, separating it from the internet. So when traffic comes through from the internet, instead of them going all the way straight to the enterprise LAN to cause havoc and chaos, they'll just typically try to attempt to cause havoc and chaos up in this area. And then sometimes within this area, they might deploy a honeypot, which is a machine that is designed to attract intruders to let them go in there and just mess around, prod and poke while they are being watched. But you'll learn about that in future classes. DHCP, or Dynamic Host Configuration Protocol. This is a network management protocol used on IP networks whereby a DHCP server dynamically assigns an IP address and other network configuration parameters to each device on the network so they can communicate with other IP networks. By default, SOHO routers have the DHCP service turned on so they can provide IP addresses to any wired or wireless device that connects. Most routers enable you to specify the range and number of IP addresses available via the DHCP. Now, in this example right here, this shows a router with a DHCP enabled and a range of IP addresses the DHCP server can assign. The default address of the router is 192.168.1.1, which you can see right here on your screen. And the subnet mask is 255.255.255.0, which that information will be plugged in right here. This means the router has the first address on the 192.168.0 network, which is a private network that can't be used on the internet. When devices join the network based on these router settings, DHCP assigns addresses in the range of 192.168.1.100 to 192.168.1.141, or 149, I should say. So essentially, they are assigning upwards of 50 IP addresses to this IP range right here. I know it's kind of hard to see, but right here it states the number of DHCP users that are going to be on the network. They have the number 50 punched up in here. And so the IP addresses are going to start right here. You can't really see it, but it says 100 right there. So from 100 to 149, any device that connects to this network, they're going to get assigned an IP address from the range of 100 to 149 is what this is saying. Now, if a router does not have enough IP addresses for the devices that need to connect to it, a PIPA IP addresses from 169.254.0.0 to 169.254.255.255, they are assigned to devices arriving after the pool of addresses are used up. A PIPA stands for Automatic Private IP Addressing, which is a feature in Windows-based operating systems that enables computers to automatically self-configure an IP address and subnet mask when their DHCP server is not reachable. A PIPA service checks regularly for the presence of the DHCP server every 3 minutes. If it detects a DHCP server on the network, the DHCP server will replace the PIPA networking address with dynamically assigned addressings. And another thing, the PIPA address, it'll let devices communicate within the LAN only, but they cannot leave the LAN to go out to the greater network, i.e. the internet. IP addressing. So an internet protocol address is a numerical label assigned to each device connected to a computer network that uses the internet protocol for communication. An IP address serves two main functions: host or network interface identification and location addressing. The SOHO router comes with the default IP address. This IP address is a special type which is known as a private address. NIC configuration steps. So a PC may have several different NICs to allow for connection to a network over the wire, Wi-Fi, or virtually. Once you select the NIC that matches the method of connecting, you can choose the protocol and configure network access. Now, the following is how to go about configuring a NIC on a Windows-based computer. What you're going to do, you're going to click the Windows icon and select the Windows settings gear. In the Windows settings window, you're going to select network and internet link. When you see the different connection options, select the one you want and click change adapter options. Choose the adapter you want to configure. And in the example that I'm going to show you on the next screen, that example is going to be Ethernet. And then you're going to click the properties button. A list of items available for the NIC will be listed. Now note that in the example on the next screen, they're going to present options for IP version 4 and IP version 6, which will be checked, which will make them available for the NIC. And after you do that, you're going to double click on the Internet Protocol version 4. You will now see the windows where the IP address is configured dynamically or statically. And then you are going to assign the address or leave the default DHCP options and click OK to accept any changes. And like I said, once you go through all those steps, you're going to end up at a window similar to this. And this window is displaying the options for going about configuring the NIC for the TCP/IP version 4, Internet IP version 4. And once you go through all those steps, you're going to end up at a screen similar to this. This one is for Ethernet properties. And as you can see, it has highlighted IP version 4, TCP/IP version 4 that they are going to use to go through the configuration process. End-user device configuration. Configuring end-user devices such as printers, mobile phones, etc. is very similar to that of configuring a NIC. End-user devices that are looking to connect to a DHCP will automatically configure themselves. Devices that need to be configured manually, the process is mostly the same as that for a NIC. To access the configuration windows, you may need to visit the manufacturer's support site. The Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. The definition of IoT has evolved due to convergence of multiple technologies, real-time analytics, machine learning, commodity sensors, and embedded systems. Traditional fields of embedded systems, wireless sensor networks, control systems, automation for home and buildings, and others all contribute to enabling IoT. In the consumer market, IoT technology is most synonymous with products pertaining to the concept of the smart home, including devices and appliances that support one or more ecosystems and can be controlled via devices associated with that ecosystem, such as smartphones and smart speakers. The software to manage IoT devices can be installed on computers or mobile devices, typically Finally, a vendor of an IoT product develops a mobile app to monitor and manage the product. Now, for the A+ certification exam, they will focus primarily on IoT devices such as thermostats, light switches, security cameras, door locks, and voice-enabled smart speakers and digital assistants. Here's a picture of a representation of a smart security system that can be controlled from your phone. So just think of the Ring security system if you have that. Personally, I have it on my own house. I control everything from my phone in terms of my alarm system. Cable DSL modem. So most SOHO networks use a wireless router and it must be connected to a modem. Simply plug one end of an Ethernet cable into the cable or DSL modem and plug the other end into the RJ45 jack labeled Internet. Attach the local devices to the wireless router with Ethernet cables in the remaining ports or via Wi-Fi. Basic quality of service. So quality of service is the description or measurement of the overall performance of a service such as telephony or computer network or cloud computing services, particularly the performance seen by the users of the network. QoS is very important when it comes to streaming media, gaming, or VoIP services. QoS prioritizes real-time and streaming traffic. Depending on the router, QoS can simply be turned on and off, which is also known as basic QoS, or it can be tweaked by specifying services to prioritize, whether to optimize for gaming and uplink downlink speeds to use. QoS can also be configured by an internet service provider or an ISP. If an ISP is performing QoS optimization, changes you make on your router will not improve your traffic. Universal plug and play is a set of networking protocols that permits network devices such as PCs, printers, internet gateways, Wi-Fi access points, and mobile devices to seamlessly discover each other's presence on the network and establish functional network services for data sharing, communications, and entertainment. Universal plug and play is intended primarily for residential networks without enterprise-class devices. Universal plug and play is widely used for media streaming across a network. Universal plug and play can also be very vulnerable to attacks. So if you do not use streaming media or other universal plug and play services, it is best to disable it. Wi-Fi encryption types. Wireless security is the prevention of unauthorized access or damage to computers or data using wireless networks. Several types of encryption are available on most SOHO routers, and you need to select and enable the appropriate one. First one we have is called WEP, or Wired Equivalent Privacy. So WEP was the first type of wireless security developed. WEP was introduced with the 802.11b and 802.11a wireless networks. When WEP was first introduced, the password could only be 10 hexadecimal characters, or the number 0 through 9, or capital letters A through F, or 5 ASCII characters, A through Z, 0 through 9 characters long. The password was encrypted as a 64-bit key. Later, WEP devices started using 26-character hex or 13-character ASCII passwords that were encrypted with a 128-bit key, which made it much harder to guess. Some types of corporate network hardware support 256-bit encryption. This can only be used if all devices on the network also support 256-bit encryption. WEP keys are generally based on hexadecimal values, such as characters 0 through 9 and letters A through F, although some devices can use decimal values, once again, characters 0 through 9, capital letters A through Z, and lowercase a through Z. The limited character set, short key length, and weaknesses in how WEP authentication takes place have made WEP obsolete. It was supported by the 802.11g wireless network, but not by later versions. Next, we have WPA, or Wi-Fi Protected Access. So a more powerful encryption standard called Wi-Fi Protected Access replaced WEP with the introduction of 802.11g. Software and firmware updates were made available by vendors for the older 802.11b and A devices to add WPA support. WPA also uses a pre-shared key, or PSK, but unlike WEP, the key can be of varying length up to 63 ASCII characters, including punctuation. The original key is used as the basis for frequent changes, and it is encrypted using Temporal Key Integrity Protocol, or TKIP encryption. TKIP has many features that make it stronger than WEP. Next, we have WPA2 or Wi-Fi Protected Access 2. So WPA2 is an improved version of WPA. WPA2 uses the even stronger Advanced Encryption Standard or AES encryption technology. When possible, use WPA2, which is also known as WPA/AES, on your wireless network. If your wireless router or access point has WPA/WPA2 setting, it can support either type of encryption on the same network. Use this option if you have devices that support WPA but do not support WPA2. And next we have WPS or Wi-Fi Protected Setup. So WPS is a network security standard to create a secure wireless home network. The point of the protocol is to allow home users who know little of wireless security and may be intimidated by the available security options to set up Wi-Fi protected access, as well as making it easy to add new devices to an existing network without entering long passphrases. Routers that support WPS typically have the default WPS key on the bottom of the device. Use the setup software provided with the router on each computer and follow the directions on devices such as printers or multifunction devices. WPS should be used only if all devices on a wireless network support it. There are two ways to use WPS: the default pin method, in which the pin on the router is used to set up clients, and a push button method, in which a physical or software button is pushed on the router and clients to set up the network. And here is a picture of the WPS setup button that you may find on your SOHO router. And finally, here are some wireless encryption standards that you may want to familiarize yourself with. Talk about open networks, which is pretty much you just connect to the network, don't have to enter any passwords, there's no encryption, and boom, you're off to the races doing what you do, while at the same time having somebody potentially steal your information. And we talked about WEP, we talked about WPA, and we also talked about WPA2. It is my advice and every other IT professional's advice to always go with WPA2, as it provides the strongest secure internet connection out there. So let's go ahead and get into some check on learning, shall we? So the first question is, when you manually configure TCP/IP settings on a computer in a SOHO network, what address should you enter as the default gateway address? Would it be the network address of the local LAN? Would it be the internal address of the internet router? Would it be the IP address of that computer? Or would it be, it should be left blank, when you manually configure TCP/IP settings on a computer in a SOHO network, what address should you enter as the default gateway address? The correct answer is the internal address of the internet router. The default gateway address is the address that a computer sends traffic to if it has no other route in its routing table. That would apply to most internet addresses. So the default gateway is the device that sends traffic out to the internet, which is the internet router. So anytime you hear somebody mention the default gateway, think of the router. Next question. This type of wireless encryption is typically found in larger companies and requires each user to log in with separate credentials. What is the name of this technology? Is it WPA2-Enterprise? Is it WPA? Is it AES? Or is it WEP? So this is a wireless encryption that is usually found in larger companies. What is the technology? The correct answer is WPA2 Enterprise. So this is an enterprise grade solution built off of WPA2 encryption. This disables shared wireless access using 1Password and requires each user to use unique credentials for access. So the big giveaway should have been the enterprise word. And then also, being that you're dealing with a corporation, and just like I told you earlier, WPA2 offers the strongest encryption. The WPA2 portion should have been the giveaway for that answer as well. Now, the final question is, in order for devices on your local home IPv4 network to communicate with other devices on the internet, your SOHO router must perform what? Is it DMZ? Is it NAT? Is it DNS? Or is it DHCP? So in order for your devices on your local home IP version 4 network to get out there and surf the internet, your SOHO router must perform what? The correct answer is NAT, Network Address Translation. Now remember, this allows private local network IP version 4 addresses to be translated into public IP addresses capable of connecting over the internet. This can also be used for IP version 6. Due to security advantages, it is less likely to be used. So network address translation is the correct answer, ladies and gentlemen. All right. So in summary, we have talked about wired and wireless SOHO networks. We talked about access point settings, router switch functionality, IP addressing, NIC configuration, end user device configuration, IoT device configuration, cable DSL modem configuration, firewall settings, QoS, and wireless settings. Now, if you felt like you got something valuable out of all of this great, wonderful knowledge, please go ahead and hit the like, share, drop a comment, and also, most importantly, subscribe to this channel for more great information. And with that being said, please go visit my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA 220-1001 examination. And until next video, ladies and gentlemen, peace.